we got a time limit exceeded. We can optimize this further. How we can optimize this? See, every divisor exists in pairs. Like if we get a divisor 1, then the pair of it is n. For 6, if there is one divisor 2, then the pair of it is 3. For let's say 10, if we get a divisor 2, its pair is 5. So divisors exist in pairs. So that is the reason we need to only go till SQ square root of n, and that would be enough. You don't need to iterate through the whole values. Let us see. Yep, I would tell you. See, let's take some examples. Okay, let's take some examples of composite number. Let's take the example of 10. Let's take the example of 100. Let's take the example of 25. Let's take the example of 64. See, if you observe that root under 25 is around 4, 4 less than 4, 3 point something. So I would take 4. Okay, let's take 4 as of now. So if you observe that 1 is a divisor of 10, 2 is a divisor of 10, 3 is not, 4 is not. Here, the square root of 100 is equals to 10. And what are the divisors of 100? The divisors of 100 are 1, 2, 4, 5, and dot dot dot. And 25 also, the divisor of this is 5. And if you observe, the prime factors till root of 5 is this. This is because prime factors exist in pairs. Okay, like divisors exist in pairs. So that is why 1, 2, 5, 10. So one value would definitely exist in root of value n, and the other value would exist in more than root of n. मतलब जो डिवाइजर्स होते हैं वो पेयर्स में होते हैं, तो पेयर का एक वैल्यू रूट अंडर एन के अंदर ही रहेगा और पेयर की दूसरी वैल्यू रूट अंडर एन से बाहर ही रहेगी. जैसे फॉर एग्जांपल अगर हम प्राइम नंबर का भी ले 5 ले तो 25 ले, तो एक 5 रूट अंडर में है, एक 5 रूट अंडर बाहर से है, 5 5 सा. फिर 1 एंड 25 एक रूट अंडर में, एक 25 रूट के बाहर में. Take the example of 16 also. Root over 16 is equals to 4. 4 multiplied by 4 is equals to 16. मतलब डिवाइजर पेयर में एग्जिस्ट करेंगे और एक वैल्यू रूट अंडर n के अंदर रहेगा, 1 से रूट अंडर n के अंदर रहेगा. That is, checking till the value of root under n is sufficient. Am I clear? Yes, this is what I have explained. One is not needed because divisors like 1 and itself is not considered in prime numbers. So that is the solution. So am I clear with this idea? Just give me a quick 1 in the chat. Just give me a quick 1. This is not what I'm interested in. I'm interested in something more beautiful out there. Okay, fair enough. Now let's head back to the problem statement that we were discussing. So what we can do is we can loop over the values of 1 to n, and the time complexity of this would be n because it loop chal raha hai n times. And inside this we can check each number if it is prime or not, which is square root of n, that is basically root under n. So the time complexity of this entire solution is n root n, big O of n root n, that we can achieve. Okay. But we have a better solution than this. Okay. Because n is looping over all the values, root under n is to check all the values if it is prime or not. Okay. Now let me show you something interesting out there. See this. अब पहले 1 आएगा, 2, okay. Now let's keep the values. Let's start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20. Okay, fair enough. We have these all values. Now see, what I say is these are the roll numbers of all the people that are there in my class. I'm the teacher of the class, and there are 36 students numbered in roll number wise. Okay, remember, I have a class, remember, a class with 36 students. A class with 36 students. And the very next thing is that the friend of roll number X is friend of roll number X is 2x, 3x, 4x, 5x, 6x, and dot dot dot. What I meant is that let's say for simple value like 8, the friends of 8 are 16, 24, 32, 40, 48, 56. The friends of 8 are 16, 24. So ऐसा एक क्लास है जिसमें 36 स्टूडेंट्स है, और एक बच्चे का जो फ्रेंड है वो 2x है, 3x है, 4x है, 5x है. जैसे 8 का फ्रेंड 16, 24, 32, 40, 48 ये सब है. ठीक है. Hope I made sense. Now let's think. So what I want is, मुझे चाहिए कि क्लास एकदम फोकस्ड रहे. I don't want any distraction. That is the reason why I would isolate people from their friends. What I meant is in Hindi is, मैं क्या करना चाहता हूँ, मैं चाहता हूँ मेरी क्लास एकदम डिसिप्लिन रहे. इसके वजह से मैं चाहता हूँ एक लड़का और उसके बाकी सारे दोस्त को मैं दूसरे सेक्शन में पास ऑन कर दूं. जैसे लेट्स स्टार्ट विद द नंबर 2. Okay. So for 2, its friends are 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So I have eliminated all the friends of 2. Then let's go to 3. Then 3's friend would be 6, which is already in a different section. 3's next friend is 9. I'm now moving it to the next section. 12 is already in a different section. 15, I'm moving it to a different section. 18 is already in a different section. 21, I'm moving it to a different section. Then 24, I have moved it to a different section. Then 27, I have moved it to a different section. Then 30, moved to a different section. 33, moved to a different section. Okay. Now let's go to 4. 4 is already in a different section. Let's go to 5. 5's friend is 10, which is already in a different section. 5 next friend is 15, which is already by a next section because of 3. 5 next friend is 20, which is already in a different section because of 2. 5 next friend is 25, which I am moving it to a next section. 5 next friend is 30, which is already in a different section because of 2. 5 next friend is 35, I am moving it to a different section. Then let's go to 6, already in a different section. Let's go to 7. 7, 14, different section. 21, different section. 28, different section. Okay, 28 is also a different section. Then 8, 9, 10 is already in a different section. Then let's go to 11. 11's friend is 22, already in a different section. 33, already in a different section. Let's go to 13. 26 is in a different section. 17, 34 is already in a different section. 19, 38, already different section. So all the people have been isolated from their friends. If we observe that what I claim is remaining focused roll number is prime number. This is what I meant. कुछ नहीं करना है. एक class समझो, all the values from 1 to n are just students of a class, and friend of a roll number x is 2x, 3x, 4x, 5x, 6x. So what I do is I'm just isolating everyone from their friends. और जो focused बच्चे बैठ गए, their roll number are the prime numbers. That's it. Take a screenshot and you would never forget it again. And of course, you can post this on LinkedIn. It would make me smile. So no one would ever ask you that what is the algorithm of prime sieve. People would ask you to solve problems over prime sieve. That is why the way to remember prime sieve can be associated with a funny example so that you are able to retain it for a longer period of time. That's pretty much the goal of this teaching. Am I clear? Just give me a quick 1 or 0. Give me a quick 1 or 0. Take a screenshot of this and you would never forget. जब भी you would see all these lines, you would remember it. Am I clear? Give me a quick 1. Sir, could you please tell the friends logic? Yep, sure. No issues. See this again. और जिसको जिसको मैं फिर से एक्सप्लेन कर रहा हूँ उनके तरफ से तो अप्रिसिएशन चाहिए ही होगा. This nation skill up is for free, but at least you should appreciate someone for free. Appreciation is something which people deserve, even if the product is free. Let's see. Let's start off. Okay. Initially, I have 36 students in my class. And a student of a friend of a particular student is the multiple of itself. जैसे friends of roll number 8 is 16, 24, 32, 40. Friends of roll number 4 is 8, 12, 16, 20, 24, 28, 32. Friends of roll number 5 is 10, 15, 20, 25. ठीक है? Fair enough? इतना तक clear है? Initially, we have a set of students and the friend of each student is the multiple of it. Okay. Now, what I want is I want a focused class. A focused class is a class which has no friendship. ओके. ऐसा ही होता है ना, हमारे टीचर्स ऐसे ही बोलते थे. हम स्कूल्स में ऐसे ही सीख के आए हैं कि एकदम दोस्ती यारी से दूर रहो. हमारे पापा लाइक आवर पेरेंट्स यूज्ड टू से इन आवर चाइल्डहुड ना, दोस्ती यारी से दूर रहो तभी आगे बढ़ पाओगे. लाइक आई डोंट नो हाउ मेनी ऑफ यू हैव हर्ड दीज ऑल लाइंस, but my parents are old school. My father is a professor and my mother is still a teacher. My father is a retired professor now, but they used to tell me dosti yaari se dur raho. So that is why for me a focus class is a class which has no friendship, just moving forward with the learnings of my father. Okay, so fair enough. So I want to isolate people from their friends. A cruel teacher. Fair enough. So one is the teacher. So ignore it. Start from 2. So all the friends of 2, move it to a different classroom. So moving 4, 6, 8, moving 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36 to a different classroom. Then I moved on to now to the student 3. Now I I was moving all the friends of 3 to a different classroom. I went to 6, but it is already in a different classroom. I went to 9, moving on to a different classroom. I went to 12, already in a different classroom. I went to 15, already in a different, moving on to a different classroom. 18, already in a different classroom. 21, moving to a different classroom. 24, already in a different classroom. 27, moving to a different classroom. 30, already in a different classroom. 33, moving to a different classroom. Done. 4 is already not in my class now. I went move forward to 5. Then 5's multiple, that is 10, already in a different classroom. 15, already in a different classroom. 20, already in a different classroom. 25, moving to a different classroom. 30, already in a different classroom. 35, moving to a different classroom. Then let's go to 7. 14, already in a different classroom. 21, already in a different classroom. 28, already in a different classroom. 11, 22 is already in a different classroom. 33 is already in a different classroom. Now, if you observe, all the remaining people are the prime numbers. Okay. Again, I'm writing the same thing. All remaining roll numbers are prime. A re-explanation of the same thing with the same energy requires a bit of appreciation out there on LinkedIn. Okay, that's pretty much. Okay, am I clear? Any suggestion? Just ask me at the end. Just ask me at the end. I don't want to break the flow at this point. Just ask me at the end. Understood? Everyone understood? Chalo, let's move forward. Now, let us implement this one by one. Okay, let's do what is said. Okay, what I did was just let us do what I explained you. Okay, just converting all the explanation to code. Initially, I have a class of n students. Okay, and initially everyone is in the class, and we are marking out something. So we need to save something. So declare a array of size n plus 1. So I would declare int array a of, sorry, array a of n plus 1, and initially everyone is in my class. So I would iterate over all the students and tell them that you are in my class. I is less than equal to n and I plus plus, and I would say that a of I, you are in my class. Okay, initially everyone is in my class. Done. 1 is the teacher. So I would mark 0 and 1. A of 0 is equals to A of 1. Them as not in my class. Okay, because they are just teachers. 1 is the staff, 0 is the staff, 1 is the teacher. Fair enough. Now I would move forward and mark the people who are in my class. So for I is equals to 2, because 0 and 1 is marked, I is less than equal to n and I plus plus. I would move forward to all the students. If they are in my class still, because when we went to 4, 4 was not in my class. Okay, so if a of I is equal to 1, that is, if this person is still in my class, then isolate all the friends of him. Then what I would do is I would need to go to I multiplied by 2. I need to go to I multiplied by 2, I multiplied by 3. I would need to go to I multiplied by 4, which is basically 2i, 2i plus I, which is basically 3i plus I. I can say this. So previous value plus I, previous value plus I. This is what we are doing. So that is why the loop would be in this fashion. For int j is equals to 2i, and then j is less than equal to n, and j plus equals to I. This is a little bit different from what you do j plus plus. Okay, because 2i plus I would make it 3i, 3i plus I would make it 4i. That is how we can move forward. So this j plus equals to I means that it would add I in each iteration. So the first value of this would be 2i, the next value of this would be 3i, next value of this would be 4i, next value of this would be 5i. So I would mark all the people or friends of I as not in my class. So a of j would be equal to 0. And at the end, whosoever is equal to 1, they would be my answer. Am I clear? Give me a quick one in the chat and make sure you take a screenshot of this, and then I would implement this. Just take a quick screenshot of this. दीदी आप थोड़ा पंखा यहाँ लगा दोगे क्या? एक पल लगा दो ना. Just give me a quick one. Okay, don't worry. I would write the code now. Okay, see this. What I'm doing is, don't worry, I would write the code. Even though if you don't understand, I would re-implement the code. No issues. Okay. So I would name it as prime sieve. I would take the value n. What I would do is I would declare an array of size n plus 1. And then I would make all the values as in my class. For int I is equals to 0, I is less than equal to n, and I plus plus. And I would mark P of I. They are like everyone is in my class. Like we are marking everyone in my class or not in my class. We are marking each one of them. Okay. So initially everyone is in my class itself. Okay. Now 0, we are marking 0 and 1 as explicit because they are not in my class. Like they are the teacher itself. They are the teacher itself. So I'm marking it as 0. Then I start off with all the people for int I is equals to 2, I is less than equal to n, and I plus plus. If this person is in my class, that is A of I, that is P of I, that is P of I. If this person is in my class, then go to all the friends of this person. Then for int j is equals to 2 multiplied by I, j is less than equal to n, and j plus equals to I. Then mark P of I is equals to 0. That just make them go to all the other sections. Let's see this in action. What is basically happening? See this. Let's see the dry run of this, and then I would run the code. See the dry run. What is basically done over here? Understand this. Okay. See. We start off with declaring an array of size n plus 1. Let's say the value of n is equals to 10. So we declare an array of size 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Then this for loop is doing what? This for loop is basically setting all the values as 1. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Done. Then we are marking the staff and the teacher as false. So let's mark the staff and the teacher as false. Then we are starting from 2. So when I is equals to 2, it is equal to 1. So it would go inside this loop. So j would be equal to 2 multiplied by I. That is basically 2 multiplied by 2 is equals to 4. So it would go to 4 and mark 0 over there. Then it is what written? J plus equals to I. So j plus equals to I would add I to the j again. That would make it 6. So we would go to A of 6. We would mark this as A of 6. We would mark this as false. Then we would add j plus equals to I. So we would go and add 8. We would go to 8 and mark it as 0 because of this line. Then j plus equals to I, add 2 to it, and it would be 10. So we would go to 10, mark it as 0. Done. Then it is out of the loop because of this condition. Then this loop would end. Then I would be equal to 3. Now 3 is equal to 1 still. So we would go to j is now equal to what? 2 multiplied by I. That is 3 multiplied by 2 is equals to 6. We would go to 6, mark it as 0. So 0, it is already there. Then we would go to j plus equals to I. So it would become 9. So we would go to 9 and we would mark it as 0. Then the loop would end. Then I would become 4. But it is not equal to 1. That is why it won't go inside this jth loop. Because we have written a statement, a checkpoint over there, that if it is 1, then only go to this loop. Then we would go to 5. Okay, p of 5 is equals to 1. So j is equals to 10. 10 is already marked. Then we would go to 6. It would not go inside this loop because of this condition. Then we would go to 7. It would go inside this loop. J is equals to 7 multiplied by I, that is 14, but 14 is out of the loop. So this condition would not, this because of this condition, this for loop won't run. Then we go to 8. P of 8 is already equal to false. So because of this condition, we won't go inside this loop. Then we would go to 9. 9 is equals to 0. 9 is equals to 0. So because of this if condition, we won't go inside this for loop. Then we would go to 10. Because of this condition, we won't go inside this loop. So at the end, if you observe all the numbers which have the index set as 1, they are the prime numbers. Am I clear with this diagram? So now what I can do is I can simply loop over for int I is equals to 2, I is less than equal to n, and I plus plus. If any of you, I would print all the indexes which are having 1 at that point. Okay. So p of I is equals to 1. Then C out I with a space in between. I think so this would do the job. Let's pass 100. Let's take int n, scene n, int n, scene n, and prime sieve of n. Okay, this would be just j, sorry. Any more mistakes that I have done? No. Yep. So all the values are the prime numbers over here. So if you observe, this is the code of the prime sieve. First position only teacher, that means no, 0 and 1 are staff and teacher. So under skip 0 and 1. Skip 0 and 1. Am I clear? Am I clear now? Give me a quick 1 and 0 at this point. Give me a quick 1 and 0 at this point. Understood, everyone? Now, let's say we want to find the smallest prime factor of all the numbers from 1 to n. Sir, explain if you want to find in particular range. If you want to find in particular range, not just from 1 to n, then you need to use segmented sieve. But segmented sieve is a rookie topic, not a beginner topic. Sir, why j is equals to 2 multiplied by I? Because the friends of 8 is equals to 16, 24, 32. And we want to isolate the friends, not him. But that is why whenever we hit a I, we go to 2 multiplied by I, 3 multiplied by I, 4 multiplied by I. मतलब हमें उसके दोस्त हटाने हैं, उसे खुद नहीं हटाना है. तो उसके दोस्त क्या क्या है? 2i, 3i, 4i. इसीलिए हम 2i से स्टार्ट कर रहे हैं, I से नहीं. Am I clear? पृथ्वीराज पाटिल. By the way, you have a very nice name. Sri Lakshmi, am I clear? If you want to find in a particular range, not just from 1 to n, you need to use segmented sieve, but that is a rookie topic, not a beginner topic. So you can learn it if you want. Okay. Another important observation over here is this is a very common question asked in FANG. Okay. I would explain you this. Very small observation. Many a times you are asked to find the prime factorization or smallest prime factor from 1 to n for all the numbers from 1 to n. So what you can do is, I would give you a very small trick to do it. One way is that you iterate over all the values of that number, and the smallest number which divides it and it is a prime, that would be its smallest prime factor. This is one way of doing it. ये है आम जिंदगी. बट एक मेंटोर जिंदगी दिखाऊं, जितना पढ़ा है उसी से हो जाएगा. Let me show you something which can be learned by just knowing what have you learned in the last 50 minutes. See this. This is very easy and very interesting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. इतना काफी है. अब what I claim is, देखो, for a human, like we have a saying na, first love can never be forgotten. पहला प्यार कभी भुलाया नहीं जाता है, पहली दोस्ती कभी भुलाई नहीं जाती है, पहली हर चीज भुलाई, पहली बाइक कभी भूली नहीं जा सकती है. The first experience of everything is so mesmerizing. After the first experience, it's all just a way of life. जैसे वो पहली सैलरी कभी आप नहीं भूल सकते, पहली मोबाइल, पहली सैलरी नहीं भूल सकते. ओके. इन द सेम मैनर व्हाट आई क्लेम इज, सबको अपना पहला प्यार याद करवाओ. दैट्स प्रीटी मच द सॉल्यूशन. व्हाट आई मेंट इज, आई वुड एक्सप्लेन यू व्हाट आई मेंट. सी, just explicitly remove to 1 because it is the teacher and we don't want to mess with the teacher. Now see, what I meant is 2 is a friend of 4. So the very first friend of 4 is 2. The very first friend of 6 is 2. The very first friend of 8 is 2. The very first friend of 10 is 2. The very first friend of 12 is 2. The very first friend of 14 is 2, the very first friend of 16 is 2, the very first friend of 20 is 2, 22 is 2, 24 is 2, 26 is 2, 28 is 2, 30 is 2. The very first friend of these all numbers are 2. Let's go to 3. The very first friend of 3 is 6, but he is not very first friend because 6 has already a friend 2. Let's go to 9. 9 has no friend. So the very first friend of 9 is who? 3. The very first friend of 12 is not 3 because 12 has already a friend 2. 15, he has no friends up till now. So 3 would be the very first friend of 15. Let's go to 18. 18 already has a friend 2. 21, he has no friend. The very first friend of 21 would be 3. The very first friend of 24 is not 3 because it is already a friend of 2. The very first friend of 27 is not 2, but so it can be 3. Now let's go to 4. 4 is already not in my class. 5. 10 is already has a friend. 15 already has a friend. 20 already has a friend. So the 25 would be the very first person whose first friend is 5. Then 7, 14 already has a friend. 21 already has a friend. 28 already has a friend. Now everyone has a friend. Now if you observe, the very first friend of everyone is the prime factor, is the smallest prime factor. Like for 28, the smallest prime factor is 2. For 16, the smallest prime factor is 2. For 15, the smallest prime factor is 3. For 25, the smallest prime factor is 5. For 9, the smallest prime factor is 3. And this is indeed very interesting and very amusing to see. The very first number which ticks off its friend is the smallest prime factor of that number. And not just this, the data doesn't stop here. You can level this up, and this is the FANG level question. Now you can take it to the next level and make it like you would be a conqueror of prime Siva out there. What is the question out there? Find the prime factorization of a number x in a very fast amount of time. So let's say you give me a number 24. I can find out the prime factorization of 24 by doing this. See this. This is an upgradation. I don't expect you to learn everything out of it. But if you get the inspiration out there and if you're able to retain it, then you might gain interest. I want to be the one who made you have interest in DSA. See, if I give you 24, you would go to 24 and ask him, 24, what is the smallest prime factor of u? Divided by 2, you would get 12. So the very first value is 2. Then go to 12 and ask him, 12, who is your smallest prime factor? It is telling me 2. So right here, 2 divided by 2, you would get 6. Then you would go to 6. 6, who is the smallest prime factor? 6 is telling me 2. Right here, 2 divided by 2, you would get 3. 3, who is your smallest prime factor? 3 is telling nobody. I am a prime factor. I am a prime number itself. So I would write 3 divided by 3, you would get 1. So if you observe the prime factorization of 24 is 2 to the power 3 2 to the power 3 multiplied by 3. Even let's check with another number. Let's make it 18. We would go to 18. 18, who is your, let's make 18. Who is your smallest prime factor? 18 is telling me 2. So I would write here 2 divided by 2. I would get 9. 9, who is your smallest prime factor? 3. I would write here 3 divided by 3. I get it 3. 3, who is your smallest prime factor? I am a prime factor myself. So I would make it 1 and write here 3. So if you observe for number 18, the prime factorization is 2 multiplied by 3 multiplied by 3. So if you are told to find the prime factorization from 1 to n, you can use prime sieve. If you are told to find smallest prime factor of all the numbers from 1 to n, you use prime sieve. If you are told to find out all the prime numbers from 1 to n, you use something known as prime sieve. So everything in DSA which relates to sieve, which relates to prime, can be solved using prime sieve. So that's what I wanted to tell you. Just a simple algorithm like prime sieve does this many things. Smallest prime factor, lowest common ancestor, then lowest common multiple, then smallest prime factor, then prime factorization, prime numbers, composite numbers, everything. Am I clear till this point? Can you please? Okay. Am I clear to you? Give me a quick one in the chat. The last upgradation of finding out the prime factorization was just to tell you that how much capability this has. Smallest prime factor is 2 multiplied by 3 multiplied by 3. Okay, whatever it is. You understood the agenda of this, no? So, to be honest, I want to give you ton of teaching out there, but I have a time constraint to respect. That is why I can't make this more than 2 p.m. IST. So that's pretty much above me. So this was all about Prime Sieve and the powers it has to unleash. So it has a lot to give you.
What is the time complexity of Sieve, sir?
The time complexity of Sieve is n log n, which is even less than n log n. It is n multiplied to a very constant value. Sir, I have done till binary search, but I forgot what I have done when I moved to other topics. Is there a suggestion from you? Do a lot of random problem solving. That would help you to revise all the previous concepts too. Matlab, don't do topic wise, because in an interview, no one would tell you that this problem is a binary search, solve it using binary search. Do problems which can be solved in multiple patterns out there. So So again, a small request from my side. Even though this nation's skill up is free and these sessions are completely free, but you can always go ahead and appreciate these all freebies out there so that people keep up the good work. Because if there is no monetary motivation, it's the appreciation which helps us to move forward. So you can post over LinkedIn. So that was pretty much from my side. Thank you and have a nice day.
Thank you, sir.
Most welcome. Goodbye, everyone. Thank you.
Thank you, sir.
By the way, this is my LinkedIn URL in case you want to tag.